Welcome to the Hazard Class Podcast. This is the podcast where I ask my stupid questions to some of the smartest people in and around the world of emergency services. My guest this week is a leader in robotics, dedicated to improving safety for first responders. With a background in electrical and computer engineering from the University of Texas at Austin, he started building robotics prototypes in high school. His company, Paradigm Robotics, developed a heat-resistant robot for hazardous environments and raised $3.95 million in pre-seed funding to scale their work. Please welcome the founder and CEO of Paradigm Robotics, Sidd Thakur. Sidd, welcome.
Hey, Jake. Thanks for having me on. Great to be here.
Of course, yeah, I'm happy to. This has been a long time in the making. We were talking prior to Southernmost Hazmat, and then we were like, let's just push it off. We're both going to be in Key West. Let's do it down there. Unfortunately, my technological skills are waning, so I wasn't able to set up the live recording for us to do down at Southernmost. So we pushed it. Now we're doing it now. But I was able to meet you, which was great. And you said you had a good time at Southernmost, but it was nice to meet you there at least.
It was great meeting in person, and I'm sorry I didn't have a robot for you. I think next time I'll make a robot that sets up the podcast studio for you, and then boom, that's a new business right there.
I know, that's perfect, right? That's a new wing of the company, perhaps.
No, we got a microphone and audio, and we'll use that.
Perfect. All right, so let's start with the origin story. I always start with the origin story. Your origin story happened a little bit more recently than a lot of my guests. At 22 years old, the CEO of a company. I didn't even think about doing anything that was beyond, drinking beer at 21. So good for you.
No, I'm still doing plenty of that. Don't worry.
But good for you. Why robotics? Why? What's the interest?
Yeah, that's a good question. Well, I'll happy to say, it takes a village to raise one, and I'm really incredibly appreciative of all the folks, such as yourself, that have helped along the way. I think the robotics thing started when I was really young. Really fortunate to my parents for putting me in an environment where I can learn as much as possible. I got started with Legos when I was really young. I think a whole generation of engineers have been trained on those things and building machines, breaking them down. I didn't get those expensive Lego sets. I got buckets of bricks and things. And so I just built little RC cars, and I tore down equipment that my parents would then be frustrated with, and I'd put it back together again, sometimes unsuccessfully. And just got really interested in building things. And that went into woodworking, and that went into all sorts of crafts. And then getting into elementary school and middle school and high school, I started doing competitive robotics, just building up from those days, and always loved tinkering. And so I just loved, making machines come to life and controlling them. So everything from an automatic watering system for my mom's garden to an RC forklift to if you know what model railroad is, model trains, big model railroader, and built a massive autonomous model railroad system with dozens of trains and cars and things like that, which is maybe how I got into train derailments a long time later. But that's sort of how I got into robotics. And fast forward a couple of years, started doing research in the space and discovered problems, and coupled with emergency response is sort of how that got it there. But that's a whole other story as well of how Paradigm started.
Do you remember the first time you saw or learned about a robot? Like the idea, is there like a quintessential childhood robot that you saw and you're like, whoa, robots are crazy?
You were talking about BattleBots earlier. That's awesome. I love BattleBots. I actually help run Texas's Combat Robotics League now. We started that a couple of years ago out of UT. But when I was young, actually, I didn't really have access to much, TV or computers or games and stuff. And so I think the first couple of robots I saw were really like vehicles and cars. And so I spent a lot of time trying to emulate those because I thought they were kind of robot-like. But I think the first robot that really has an impression in my mind is Wall-E. Like every kid in my generation, which is the same generation as yours, don't worry, we're all not that young. But I just remember seeing Wall-E going like, wow, how did they make that thing? How does it collapse into a box? How do his arms move? How do his eyes go up and down? And it's so cool if you look at Disney, They have something called the Imagineering Studio, which is where they make these like things come to life. And they built a Wally recently, like I think 1 or 2 years ago, and it's incredible how detailed and lifelike it is. And that like kid in me is like, that is awesome. Like I'm so excited that kids can see that. But yeah, that might have been like the first like character that kind of inspired things.
So when you think about robotics, right? And you have to forgive me because I am as rudimentary in my understanding as you can imagine.
No, you're great.
Is what comes first, the chicken and the egg, in terms of understanding the back end systems versus the hardware? Is it a hardware problem first or a software problem first in terms of making things
Mhm.
happen?
That's a great question. I think that is the trillion-dollar question right now that investors and startups and all sorts of companies are racing to solve. So if I have the answer, man, we're gonna we're gonna go big. But I think the answer is it's a little bit of both. I think one of the problems we see is if you make great hardware, but it's dumb, then it doesn't serve its purpose. But if you make great software and the hardware fails, well, then you can't deploy it in the right environment. So it's really a combination of having the two at the right time that work well together. And the way we like to think about it, the way I like to think about it is, well, ask the users who are going to be using the thing, what they need, and then build from there and really iterate and improve with them. And so I think you have to first start with hardware. Got to start the base platform, build the software that enables it to do the things, and then slowly improve that over time because software you can rapidly iterate, and hardware is in the name hard, so it can be harder to improve that. And that's kind of the philosophy we take is build a great platform and then work with the operators and users to then improve that software, which you can improve over time. But really, it's a question of doing both. And I think there's a lot of companies like working a race to solve that right now.
When you're thinking about initially getting into robotics, like say not like you're beyond your Legos or maybe your Connects, or that Connects were big for me.
Oh,
I
I
love
love Connects. Yeah.
Connects were great, right? I had to get on a side tangent because I love side tangents. My
Huh?
parents for Christmas one year bought me like the Connects roller coaster. It was like
Oh, I had that one too.
it
Yeah.
was it was the coolest toy. I've been trying to explain it to my kids about how like your toys suck now. Like
Yep.
like we had the coolest toys in terms of like these
Connects was
Connects
great.
with this like 5,000 piece roller coaster that took me like
Yep.
6 weeks to build. It's like a
Oh
full
my
on
goodness.
construction project.
So that
But
explains all your like technical and engineering, man. Like I'm surprised you didn't go down the robotics route. You could have,
Well, that's
I
because as
love
soon as the
Connects.
math started mathing, then I was like, ugh, maybe I will go into burning buildings. That seems like a more doable thing to me. Um, but
It's a
so we
roller coaster
think
of
just
different
beyond
sorts.
the ledge, and even some of those, like nowadays, they've really started to add more STEM components into some of these early learning things. But I imagine at some point you had to make the leap from, you know, kids things like in terms of Legos or Connects or pick the thing to like you're actually going to build a robot in some way, shape, or form using some sort of platform. Did you have to have any bit of coding knowledge at that point to make things happen,
Hmm.
or did you kind of figure things out at I guess to round this question off, it's like, did you have to hit the books before you could even start? Or is there any component of like, if you're doing woodworking, you can grab a
Right.
piece of wood and start nailing it together, and it might be the worst
Yeah.
woodworking of all time, but you're doing it. But what's the barrier to entry to even get into robotics at all? Is there have to be some foundational knowledge to exist first?
Really, really good question. I think I'm blessed. I think in early 2000s to mid 2010s was really the explosion of the internet in a lot of ways and really internet-based education. And I think with robotics, what happened is as education moved more and more online, a big second thing happened, which was the cost of hardware components got cheaper and more readily available on Amazon, on eBay, Radio Shack. And so what's really cool is, coupled with really cheap, low cost, accessible components and internet education, I think anyone can get into robots nowadays. And you talked about like going from the Legos, the Connects to like maybe the real world, if you will. What's really neat is Lego has Mindstorms or EV3, which is like motors and power systems that allow you to sort of get there. And then you can move into maybe some off the shelf components you can buy from like Amazon or something. And you can really honestly cobble together something in a weekend. Get some motors, a microcontroller, which is just a computer, maybe some sensors or a camera, get some wires and plug them in and pull up a laptop and you can code away. And, when I started working on robots, we didn't really have the current AI or large language models, but it was still just as easy to find some code that was online, copy and paste it, improve it, or watch a YouTube video. So it's super awesome. You really don't need a formal education. You don't need to hit the books. You can just start learning right away. And the tools that kids have today are 10x what I had then. With these AI models and things got even cheaper. It's you can just hop right in. And I think what's really neat is building something in the real world while doing education is great. You coupled hand in hand. And I started to do my first real world projects by, starting to work on robots for wildfires or structure fires or irrigation in agricultural fields, some of my early projects. And that's when I started, improving from just, prototypes and then learning about the environment and reliability. And so I think, yeah, to answer your question, really easy to get started. The internet is incredible, an incredible resource, and components are very cheap
Hmm.
online.
So let's go backwards a scotch again. What was and you talk about this environment that fostered learning and you kind of the environment that pushed you into this early on, like what's the family dynamic? What did your parents do? What were they pushing you towards any sort of particular STEM field? What was that dynamic like?
Yeah, I think it's something I'm so grateful for again. I think my parents, both of them studied engineering, and they went into engineering management, and then became executives, corporate executives. So worked in healthcare and railroads, worked in engineering and robotics. But what's interesting is my parents have also an entrepreneurial side to them. Both my parents set up, started, built, and sold businesses of their own. And so I remember being really young and helping package my mom's latest product that she's selling, or helping watch or give feedback on different, marketing videos she's doing. So she's incredibly entrepreneurial. And, fast forward many years, she's now founded, advised many startups, including my own, and she's one of our most active advisors. And so my parents are incredibly engineering and scientific oriented and very analytical and incredibly smart, but they also have that entrepreneurial flair. So maybe that's where it came from. Um, but that environment when I was young was really just open and kind of like open for creativity. Like I grew up in Wisconsin, and I was really outdoors. I was fishing, I was swimming, I was biking, had a lot of freedom and creativity. And I think that allowed me to really think about things. And I'm really grateful for that, where anything I did was kind of encouraged, and supported with like Legos or Connects. And I think that coupled with parents that really continuously also pushed me for success and like whatever I chose to do, whether it was soccer or piano or robotics, they gave me that ability to experiment while also at the same time pushing me to excel in sort of whatever I chose.
So that leads you to choosing this, this pathway of working in robotics. So we have one pillar of how you are who you are, right? But now we have to tie in there's a billion things to do with robots. Why the emergency services?
Yeah, no, I know. I think I think a lot of firefighters, come from families oftentimes, and I think that could be a great connection. I didn't really have anything like that. For me, really, it was sort of natural. I think I really spend time trying to understand the problem. I'm a people person. I'm a humanitarian. I love to help people, my neighbors, my family. And when I was young, I spent a lot of time trying to think about like what are the problems I want to solve. And so I started thinking about, wildfires when I was really young. It was all over the news. It seemed like a big problem. It was getting worse. And I was like, well, what if there's a way I could take my prototyping electronics robots to that? And so I was working out of the Houston Community College at the time, excuse me, and with my mom's support, I started to research and like tinker and make a little device that could help firefighters do early detection of wildfires. It was an early prototype of something that can detect smoke in the air, and look for flames and assess heat. It's a big market nowadays, but this was back in the late 2000s, and so I was tinkering, I was building. It was a great prototype. I got some feedback, some from firefighters, and I wrote a little paper on it. But what happened was I started meeting some firefighters from Houston, and started to get to know firefighters from around the local area. And I started to learn about the problems that they face. And these are more structure firefighters, less wildland fire firefighters. And at the time, there were some large structure fires. Unfortunately, an example is the Southwest Inn fire in Houston, Texas, which ended up killing five firefighters. Um, and stories like that of firefighters unfortunately dying in structure fires due to whether they were doing search or active attack or is due to roof collapse, started inspiring me to ask questions of why did this happen or how did this happen. I'm trying to solve this mega global problem of wildfires, but there's problems in my local community in Houston. And so I just started reaching out to fire chiefs, going door to door. My mom dropped me off at fire stations and reached out to fire chiefs in Missouri City, Houston, Pearland, Sugarland, Ponderosa, and just asking, what happened? How many structure fires are there? How do firefighters search them? How do firefighters do suppression? What are problems that they have? And those questions kind of just led me down the road to seeing that there might be a way that technology could support the fire service and that robots could be a solution to some of the problems that they were telling me.
So I have so many questions. How did you go about? Because you speak about things correctly, which is a weird thing to say, but hopefully it's a compliment because it is. Like the way you describe things, you're speaking correctly, and if you didn't have any bit of firefighting knowledge, you wouldn't be able to say the sentences you're saying, which is good, right? How did you go about gaining that like foundational knowledge of the idea of doing a search and doing a primary and these are like terms that are synonymous inside the fire service, but like if you talk to the average person off the street, they wouldn't even understand that at all, right?
That's such a high compliment. I don't know if you know how much that means to me. I really appreciate it. I think it was never something that was really actively done, but it was actively done. And what I mean by that is from day one, my core has been like talk and learn. And the fire community is incredible. Every house I've been to has been the most affable, friendly individuals that just share knowledge so readily. And I think what I'm so grateful for is since that day one when I went to that first fire station in Missouri City to today when we've been to hundreds and hundreds of fire stations across the country, talked to 14,000 firefighters. I've learned that lingo, that phrasing, that terminology. But it's I think it's more, and I'm sure you know this, it's more than just the phrasing and the words, it's really knowing what they mean or what they meant or how they even mean and understanding the regional differences or cultural differences or how they're actually applied, like primary attack to someone could mean three different things. Bunker gear versus turnout gear means, the same
Mhm.
thing, but different phrasing. I think everyone has their own kind of understanding and building that up is just being open-eared, open-minded and asking the right questions and then having great firefighters who always recorrect me and teach me things. And I'm sure I'm going to learn something today. Jake, you've already taught me things. I think continuing to refine my knowledge is how you do it.
Yeah, and I think that, the fire service can sniff out like the BS detector in the average fire station is so good that like it's so important. I'm happy to see that you are doing the work because nothing stinks more than when a sales rep or someone wants to come and talk fire shop and they don't say the right words and you immediately know you're reading a script, you don't actually know what you're talking about, right? So it's nice when somebody
Yeah.
like who's trying to quote unquote solve our problems actually understands what they are. So that brings me to the next point is like if you're going to build this robot, you're going to start this company that's going to work to engineer technological solutions for the fire service, right? In your discussions, you say thousands, if not tens of thousands of people you've talked to along the way. What are the pain points that you're identifying inside the fire service?
Wow, that's such a good question. I think what's interesting, you touched on something there, which is, how do you actually know beyond just conversation? And I think a thing we started to do really early on was ride outs. So now I've been on dozens of ride outs. I've Done many write-ups where I'm there for days, there for multiple shifts, and just observing, going to scenes, doing searches, doing first through four alarm fires, supporting if I can, and then also training exercises. Has large scale hazmat training exercises for regions or large scale regional training for any sort of activity. So I've learned a lot and seen a lot from there. But to answer your question about like what pain points, I think after talking to tens of thousands of first responders over, a decade now, things I've seen changes as well. I started from talking to fire departments where the problems were often, it's safety, firefighter safety. Folks still aren't wearing SCBA, or they're not, using proper tactics, or they're incredibly aggressive, which makes sense for a lot of departments, but can also put them into challenging situations. And we've also heard of a lot of recent problems, with emerging threats like lithium ion fires and EVs. Not just because it's a new threat, but because there's a lot of unknown information and information that constantly changes. And there's a great class at the Southernmost Hazmat Conference about this too. And I think one of the challenges with it is it's, you know, all fires hazmat, but this is a very hazmat. And I think the problem is a lot of people aren't approaching it that way. And so that's, of course, a recent threat that's affecting everyone. But I think the broad challenges we really see are being asked to do more with less. If you break down the fire service, the majority is volunteer, you have combined, and then, some career. But the problem is really across the board, over the decades, what we're really seeing is more and more tasks are being added to the fire service, emergency response. Of course, EMS is getting more and more, average 70, 80%, some 90%, some departments. And sometimes funding can be taken away, or sometimes more tasks for WMD, CBRN, arson investigations, fire prevention, protection. I mean, the scope keeps expanding for departments, but staffing is going down, right? Like we can see, I'm not going to name departments, but I know departments where, cadet classes are a third that they were a decade ago, or interested applicants are a fifth what they used to be. And with inflation rising higher and higher, and salaries having to match and be competitive, it's tough. Um, and now you take all the flip side with the challenges of firefighter safety, which I started with. I mean, of course, every injury and fatality is terrible, and it's a case study which should be studied. I think we're seeing some progress and improvement, which I'm so happy about, but also seeing new kinds of problems, like, of course, cancer, and carcinogens, and I think really understanding like long-term health effects, and mental health effects, right? And I think those two big things are continuously being investigated and learned about and are expanding. And so those are really the problems we like to think about, is doing more with less, um, more and more tasks being added to the plate, new emerging threats such as lithium ion, whether it's BESSes or EVs, and at the same time dealing with new generations of firefighters and recruits that are looking at the fire service going, is this a career I want to enter? And what are the benefits for me, and how can I really drive change?
Mhm. So before we get into how robotics and technology will solve a lot of problems in the fire service, I'm going to throw my firefighters that I know that are listening to this a bone. Tell me the things you see inside the fire service that you do not anticipate technology ever solving, or you do not anticipate robotics or some similar field being able to do better than a human.
Oh, that's the $1 million question. I think I'm going to start with a brief tangent to answer that question. So when I started working on robots for firefighters, I very quickly learned that in the fire service, of course, you have firefighters, you have chiefs, and you have everyone in between. And there's definitely cultural differences and knowledge differences and generational differences in between the two. And I think a lot of things we learned was that some things that we thought that would be good for certain use cases wouldn't really align with maybe folks who are in leadership, or folks who are at the city council, or a board, would align with firefighters. And so we really quickly learned early on that we need to work with unions. We need to work with firefighter unions. And excuse me. So when we initially started building robots, our primary use case was primary search. And we were looking at every kind of structure, and we learned very quickly about hoarder homes and about the bread and butter structure fires as tiny, single family dwellings, and how fast firefighters were getting to the scene, going in, looking for things, knocking fire down. And we very quickly learned that, okay, robots might not be good here. We're not fast enough. It's hard to deploy. Um, Firefighters are incredibly great at navigating through these complex structures, and this is a great place for firefighters to do. But folks started saying, well, what about big box fires or Walmarts or Amazons or warehouses? Searches in those things can take a long time and they can be hazardous, or you can get lost. You can lose sight of the line, or if you're using rope, that could, get distracted. Or maybe you're not looking up in the ceiling and there's heat behind, your second ceiling, and, there's collapse about to happen. And so we said, okay, well, maybe robots are better there. And so I think as we learned about that, was an example of us understanding like there's many, many situations where firefighters are incredible. They're creative, they're problem solving, they're quick, they're doing, the job, and they're protecting life, property, and environment. And I think there's situations where robots can support those firefighters in those high hazard zones. And a great example of this is along the way, folks said, can we put a monitor on it? Can we do suppression, right? Can we do defensive or, offensive attack and go into structures? And what's really interesting is, we learned that it's not about like, can you put a monitor on, but it's should you? And we've learned that a lot of firefighters love to do suppression, love to do attack. And, why are we putting the wet stuff on the hot stuff? Why are we trying to take that away? You know what I mean? And so we learned quickly that there's also cultural things, and we want to make sure that the jobs that we augment are not ones that are very fun to do or very critical, or things that people want to do. And so that's how we've really tried to find like what are the sticky, hard, uncomfortable, scary, complex, not fun jobs that people want to do, and then support them with robots. Um, and so maybe that was a roundabout way of answering your question,
Yeah.
but basically, I think there's always a situation that firefighters are great at doing, and robots will just augment and support around the edges.
Yeah, that's the classic. The thing about the fire service is that we have too much time to sit around and talk. So if you do that, it just becomes like, for lack of a better term, teenage girls sitting around the lunchroom table, and then everyone just like complains about everything and worries about everything.
Yeah.
That's every
Yeah.
firehouse table in the world has that problem. So
Yep.
the problem is as soon as people start thinking about robots, the first thing everyone thinks is, we're losing our
They're gonna
jobs and
take
we're
my
doing all this
jobs.
thing. And then you come to talk to a person like you. I've talked to other people kind of in the field that are like, no, 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 settle down. There'll still be a place for firemen in the world, right? It's what
That's true.
tasks can, and I don't think, um, I think we're all goal oriented. Like if I put myself in the shoes of speaking for the entire fire service, which is a really big shoes to put myself in, but I think we're goal oriented. If a robotics company can say we can do this job as efficiently with less risk, then people will be on board with that, right? The reality is like the only way to do it though is for it to truly be as efficient, and then you add the safety, right? But if as long as the only thing you're gaining is safety, if the job can be done with skin and bone more efficiently, then the fire service is always going to want to demand to do it that way. But as soon as you can say it can be done with the same level of efficiency without any skin in the game, now you have a product that is worthwhile. And I think that's probably
Sure.
the goal you're chasing, right? How do we make the task equally, if not better done, but still reducing risk, right?
You got it. I think that's the key is outcomes. I think very early on we realized that, to your point, firefighters are incredibly smart, rational, logical most of the time. And I think seeing something done more efficiently and safer, no one wants to see their buddies get hurt or injured. And I think as long as they can do that job more efficiently, whether it's time, effectiveness, or cost, if that's a question. And so we started to get metrics with Firebot, right? Like we started to deploy and learn. And so we learned that Firebot can do hazmat recon 24 times faster, never run out of air, take a multiple hour, multiple week incident to, 24x that time. And that's the kind of metric that really supports and drives, because then the firefighters go, wow, I can do that same task that I've taken, 3 teams of 2 or 6 teams of 2, these many hours or days, and I can shorten that. And I think you're absolutely right. That drives a lot of conversation, and I think that drives results too.
So now let's get to the other side. No more talking about what it can't do. Let's talk about what the hopes for the future are in terms of what it can do and what it can do better than like what. So first off, let me step on my own toes and back us up. Talk to me about Firebot. What is the platform and what is it designed to be able to do?
That's a really good question. It's come through many variations over the years. We're an early stage small company, and so I spend a lot of time trying to learn from firefighters and emergency service personnel. What do they want? What do they need? And so Firebot, broadly speaking, supports emergency response operations. And we have two platforms. We have a small one, sorry, we have three. We have a small one, a medium sized one, and an even larger one. And we support a wide variety of tasks. So our small platform supports hazmat recon and characterization. So it's getting first eyes in the scene, looking for source of leaks, source of spills, looking for placards, getting information, understanding the scene, and giving that data back to first responders. So the IC can make decisions on what to do, how to size it up, and of course, actually start to clean up, remediate, and so on and so forth from there. And this robot, and across all of our robots, is incredibly rugged. It's fully deconnable, explosion proof. It's Class A plus plus rated, if you will, and it's designed to stand 36 hours and go through terrain, rubble, debris. So it's essentially designed as a platform to go into the most hazardous IDLH environments to get data for you on what's happening. And so a lot of the work we do is spills and leaks, explosions, derailments, large fires, any sort of hazmat event. Our medium-sized platform is again incredibly rugged, but this time it's also designed for high temperatures. So it's able to go up to 1200 degrees Fahrenheit for 15 minutes and then bunker gear rating for an hour. So it's able to go into structure fires or go, into large refineries or industrial facilities near very, very high temperatures of more petrochemical fires. And we can do tasks such as still hazmat recon, suppression, primary search, RIC, resupply, carrying bottles up and down stairs to a stage, carrying equipment or a med pack or a chem kit, closer to someone, pulling skeds, so helping pull firefighters out of someone, or just gathering data, like looking for hotspots, extension, looking for the seat of the fire, understanding what's happening. And then a really large platform focuses on industrial firefighting, so flowing a couple thousand gallons per minute, really getting close to these large fires and putting wet stuff on the hot stuff. And it's just a much larger robot. So to summarize, they're robots designed to go into IDLH environments to get data back, do tasks that are challenging or risky or unsafe, and do all this from a safe standoff away. And we have sensors, thermal cameras, visual cameras, two-way audio, gas sensors, so monitoring the air, whether it's PIDs, VOCs, we have a bear claw, rad meter, and all sort of integration with 100 plus sensors. And then we do all that a couple hundred miles away, line of sight, 10 concrete walls, no line of sight. And there you go.
Wow.
That's our robots.
So yeah, just like you downplay it a little bit. So I have a couple questions about these designs. So you build a robot and then you go, I want it to be explosion proof. How do you make a robot explosion proof? Like, how does that work?
That's such a good question. Yeah. So there's two kinds of explosion proof, which is funny for any PD folks or EOD folks or service members here, if you're listening. We do EOD work, explosive ordnance disposal work, and we do work for our troops. And we build robots that are bulletproof and explosion proof, meaning they can withstand like spall or shock. And what I mean by that is if there was an explosion nearby, could it withstand the pressure and change in pressure and some of the debris attack from it. That's one kind of explosion proof that we designed for. But one of the hardest ones, which you might have heard about, Jake, is intrinsic safety, is what a lot of folks in hazmat call it, is can you design a product to go into an atmosphere that has flammable gases and not ignite the air and not cause an explosion? So most folks call it intrinsic safety, which is a method for achieving explosion proof certification, which means you won't cause an explosion. And that's really hard. And the question of how to do it is one of our, secret sauces, if you will, but it's just an engineering problem of making sure everything you design doesn't spark, everything you designed is a way such that if it did spark, there's no flammable gases there. And then at the end of the day, everything is regulated and certified by independent third-party labs and bodies. So um, just an engineering problem is what I like to say, even though it's a
Wow.
hard one.
Yeah. And so then this might be the same answer. So if the answer is the same, then you can just defer it. But
No, you're
like,
good.
I think you go from one to the next, which is then how do you make something fireproof, right? If it's going to withstand, it's
Yeah,
theoretically in my brain, at least, it's all wiring and circuit boards and
all gonna
steel,
melt.
right? So the steel heats up, it transfers the heat to the wires melt, and you have a problem, right? So how do you make that
Yeah.
not be the case?
Oh my goodness. No, that's such a good question. So what's interesting is we talked about explosion proofing, which is designing something that doesn't cause an explosion in flammable atmospheres. A lot of hard engineering to make it not spark, make it safe, make it sealed, make it pressurized. But what's interesting is a lot of that translates over to the hazmat and chemical side, which might be your next question to ask. But what's interesting is they're all very hard problems. I think of them as fire, chemicals, and hazmat, and explosions or flammable atmospheres, like three parts of a trident. The fire question was what we first solved, heat. When I first started building these robots, it was no one has ever made a robot go to these high temperatures before. And we really asked ourselves, like, what temperature should we go to? We initially started designing for thousands of degrees, but firefighters said, well, there's no one going to be in there at that point, right? They won't be alive. And so we've kind of chose the temperature of flashover as our goal, where we might need to go through some rooms that are currently in flashover, post flashover, and to get to a safer room. And to solve that problem was a lot of hard engineering. It was material science. What materials can we use that can go in these temperatures? It was thermomechanical. How can we slow heat down from moving through the robot? It was electrical and it was chemical. What materials are there that can absorb heat, maybe, or what materials are there that can, run in higher temperatures for longer? The truth of it, Jake, is heat is really three prongs. You have convective, radiative, and conductive. And you just kind of solve for each. So like radiative, if you look at our Firebot, it's pretty public. You can see a lot of reflective things on it. And so we built this technology that radiates 99% of radiative-based heat in a specific spectrum of fire, which keeps it really, really cool. But then, like you said, then there's heat transfer to the next component. And so we think about, okay, how can we slow that down from going to the next thing? So just engineering problems along the way, slowing heat down, using materials, placing components properly. Um, and at the end of the day, we want to make it really maintainable and serviceable. So don't make it so complicated that it's too expensive or too hard for firefighters to maintain. But we've been fortunate enough to say we've mostly solved it, and we've done tests now to thousands of degrees for a few minutes, 1,000 degrees for 15 minutes, and a couple hundred degrees for a few hours.
Wow. Um, I would imagine that you already alluded to the idea that you probably know my next question, which is, decon and chemical safety in terms of that. Not when I think of it not only as the ability to make sure you can clean off what gets on it, but also making sure that it doesn't trap anything and bring it with, right?
Yep.
So, how much of these problems coalesce in terms of I solve one and it also inadvertently solves another? Is there a lot of that?
Yeah, that's a good question. There's some of it that overlaps and coalesces, and some of it that completely does not align. An example of that is to be explosive rated. One technique is to be fully sealed and pressurized, which we are, which solves the problem of, to your point about things getting inside. They can't in a robot because we're fully IP67, maybe IP68, we're certifying, but also pressurized. And so things can't get in, which is great news. But there's other things that don't overline. And what I mean by that is in explosive atmospheres, you can't spark. And so how do you think about materials that don't spark, but are also resistant to chemicals, acids, corrosive spaces, all the things in the ERG? And there's not a lot of things that align. And so it's an engineering effort for us to think about, how do we find parts or materials or techniques that allow us to your point, not just be deconable, but actually withstand those environments. And then at the same time, not bring those things back. It's really hard. We're the first robot that does fire. We're one of the first robots that does explosion rating, and we're one of the first robots that does chemicals. rating. So putting all three together definitely makes us super unique. But the engineering team loves a challenge, and there's enough overlap to where some things are feasible and some things are just a problem that that we're solving and are have solved already.
This podcast is brought to you in part by Hikes Boots. You can tell a lot about a brand by the way they choose to advertise. And Hikes didn't ask me to say anything specifically. What they did was they sent me a couple pairs of boots and they said, try them out. And that's the kind of trust in products that really impresses me. And I've had them for a few weeks. I've worked a couple fires with them and my feet are loving it. They're as comfortable as sneakers, but they feel super supportive. I'm really impressed so far. I can't wait to keep using them. But if you want to find out more information about them, check it out at hikesusa.com. That's HAIXUSA.com, or you can check the show notes for a direct link. Today's episode is also brought to you by Rigaku Analytical Devices, who are the folks who have been perfecting the 1064 nanometer Raman longer than some of you have even been doing hazmat. They are launched their 4th generation handheld analyzer, the Icon X, built specifically for real world stuff hazmat teams deal with every day. We're talking about dirty powders, mixed materials, dyes, colors, and all things that make other instruments throw a tantrum. The 1064 nanometer laser means reduced fluorescence, so you get fast, reliable chemical ID in under a minute, instead of staring at a blank screen wondering what went wrong. And this new platform isn't just an upgrade, it's a whole new toolbox. It supports new accessories, including standoff analysis, so you can get answers without getting too close. If you want an analyzer that's been evolving right alongside the hazmat world, check out Rigaku's new Raman at rigakuanalytical.com or check the show notes for that direct link. Back to the show. Okay, I have a question. There's a chance you might not be able to answer it because it's a secret or whatever, but
It's okay.
So as you bring up the idea of this robot being pressurized for the sake of explosion proof, my first thought is pressure vessel and heat is a bad thing, right? So
Sure.
if we're going to make something pressurized, that means if we expose it to heat, that interior atmosphere expands and we make increased pressure theoretically. Do you have to contend with that in some way, shape, or form and engineer that problem out of it?
That's correct. Yeah. So that is a problem that we have engineered and solved. Our pressures are really, really low. You need very, very low pressures, just enough so that air or bad things don't come in. So there's one thing making a product that's watertight, and we're a watertight product, but we're an airtight product, which is a order of magnitude higher and harder. And so the safety and certification around seals, around security is so high that our batteries, for example, are in multiple steel compartments that are flame proof, explosion proof, and fully sealed. And so there's no way really for that pressure to escape except for taking a very, very long time. And because it's so low, the pressure, and I can't give specific numbers, expansion at the heats we track is very little, almost negligible. But importantly, actually, we have sensors inside that track it. So we have a purge detection sensor that tracks how much pressure is inside, if there's leaks and things like that. And so we're constantly alerting the user of that nature. I think a good question to ask is on sort of that topic of overlap is, our track technology, for example, is one of our patents is on our tracks. And so tracks designed to go in all these environments, you have to really think about, it can use metal, they're great for high temperatures, they grab, they climb, they grip. But then in chemicals, the stainless, what does it corrode in, right? What acids does it not handle well, right? So can we use a different kind of metal? And so I think a lot of that is just like the engineering aspect of it, and then just testing. We do so much tests to certify because, I'm sure you've seen chemical sheets, from PHMSA or from a NIOSH or from DOT, and there's hundreds of commonly transported chemicals, and we go for the hardest ones, HFL, HCl, sorry, HF, HCl, and then really every category. And there is a solution to the problem is all I'm going to say. But yeah, to answer your question about pressurization, we did engineer and solve that problem. And that is one of the things we had to contend with.
So describe to me in my brain, I'm picturing a semi-modular design, right? We pick the small, medium, large, and then I say, these are the components I want on it. Is each device custom made for the end user? Is there like a standard setup and you can augment it, or how does the modular nature of each one of the sizes work?
Really good question. So it's a couple things. Um, I think the best way to answer is the goal and kind of how we do it. The goal is we want to make it as self-serve as possible. We want it so that fire departments and hazmat teams and emergency response teams can just choose the base platform and, like you say, choose what attachments they want. Our ethos for this really is to bring costs down. We want to think about hazmat teams have so much great equipment today. They can just slide it on our Picatinny rails, plug the sensor in via the cable, Ethernet, USB, SPI, any sort of interface that they need, and just get their data back now in real time from a significant safe distance away. And so that's the goal. And we're really fortunate to have been able to do that. But the truth is, what we've learned is that fire departments also like customization. They like the ability to say that, this robot was spec'd for them the same way a truck might be spec'd. And so we do offer customization, whether it's, coloring or painting or labels, which of course change properties for hazmat and fire when you're sending it into an ideal H. But also it's things like, okay, can we integrate with this software or this, EOC software? Or can we integrate with this COP? Or can we integrate with this, platform that we're using? And we do offer that. So we spend a lot of time doing integrations, making sure that the data we use actually gets into the right hands. We work with, drone softwares and things like that, so we can actually display our data into what the end user needs. Because I think the problem is if you just make a glass door BC ecosystem, sorry, a glass walled garden, no one's going to use that, and integration and making partnerships and being friendly is the name of the game. And that's kind of our motto. So anyways, to answer your question, super modular robot, plug on your sensors, choose your attachments. We'll offer some specking to support the use case. And then of course, training and servicing. Oh, one additional component, which I think is really critical, is you can't kind of just like sell a robot and, set it, forget it. We want to make sure that like you can actually deploy the thing, right? So like some departments we work with trailers, so large trailers. Some departments we integrate to their BC, but most BCs are super packed. So we look at, do they have a rescue? Can we integrate into a compartment or spec into a new truck? We partner with some large fire department, some large fire truck manufacturers, so we can spec into new trucks. And then also, do they have a hazmat truck? Can we, drive off the back of that? And so part of the goal is like not just make it a very one-stop shop buy, but also spend the time to make sure they can actually use it. It doesn't sit in a warehouse for the next 6 months because it's some shiny object. It's actually, going to get use. Our North Star for the company is number of deployments, because our goal is to save lives and save injuries. And every time we deploy, we can potentially do that. And so that's just how we support that, is don't make it a shiny thing that sits in, warehouse, make it a thing that folks are using and getting on the field.
So with that, you kind of mentioned the idea of onboarding and training and deployment. Like, what's the learning curve for a device like this? Like, is this a thing where like it would be realistic for everyone on the fire department to know how to use it, or is it like we're going to have to choose a handful of people to do it, or a small group, or how difficult it is to actually use this thing?
I hope people give you kudos in these things, Jake. You ask great questions and like you really know how to like touch on the next subject. So I appreciate that.
Thank you.
The training is so critical. Like I think the goal is definitely everyone can use it. So far today, we've done some demographic studies and we've had dozens and dozens of users test the robot. Everyone from chiefs near the end of their career to early rookies and everyone in between. And the average time to get up onto speed on the sticks, as we like to call it, is anywhere from 5 to 15 seconds to tops 2 to 3 minutes, really fast. And I think the key to that is we've just started by working with operators. And when we first started talking to end users and operators, we said, well, have you used previous ground robots? What did you like? What didn't you like? And a vast slew of problems emerged around ruggedness, around battery life, around wireless comms, around usability. But one of the biggest subsets was they just didn't like to use it. The average training time was 30 minutes to 60 minutes. It took, 30 minutes to turn on sometimes. They took specialized courses. They were complex and hard to use. The cameras didn't look good. They were crappy resolution. They didn't really point the right directions. The UI, UX was a nightmare. People got dizzy, so many reports of dizziness. So all of that we took back and we said, okay, well, let's solve each and every one and then bring end users into our lab or go out to the field to the training range and test and then just improve and improve and improve and improve. And to answer your question, basically, that's how we've kind of gotten it down, where folks really love to use it. They love how responsive it is, how low the latency is. We're usually at like 2 to 8 milliseconds latency. The resolution is very high on the cameras and they're at the right angles to look great. We've done the work to make it delightful, if you will. In terms of training in the long term, what we see though is it really depends on department. Some departments have robotics teams or drone teams. So usually we'll either station with them and they'll have a few trained operators. We'll do a 1 to 3 day training course once a department gets one of our units. We'll train the trainer, if you will, and we'll set up manuals, videos, systems so that they can do refreshers by themselves every month, 6 months, 1 year. We usually see that quarterly to biannually is good enough to retain proficiency on the thing. It's pretty easy to use, pretty easy to pick up. We've designed it such that not only can an average person pick it up really fast, but if you're at a scene, it's not just about being trained on it, but you're very stressed out. There's a lot of stress. There's a lot of compounding events. There's a lot of information being thrown at you. And so we've designed it such that you can hand it off to other people at the scene. If you need it, you can bring them up to speed. And importantly, we don't throw all the information at you, all the symbols, all the lights, all the data. You get to choose what you want to see. We hide a lot of things. If you want to see it, you can choose it. But importantly, we work with you to figure out like what's information is important. Oh, the temperature. All right, we'll do an alert. Or if we're going to be using, a multi-rare, we're doing a 5 gas measurement. What levels do you want to set to alert the user? Don't throw in all the camera screens, just one. Reduce that operator burden. So, anyways, I'm just kind of going through the playbook, but long story short is we usually do a 1 to 3 day training course, refreshers along the way. Usually work with the drone or robotics team, but we end up having some departments that have their BCs or their lieutenants or captains end up operating this thing as well, or
So
drivers sometimes too.
talk to me about this UI, right? So like, what am I envisioning? Like say I'm operating this thing. Am I looking at a computer screen and I'm holding an Xbox controller? Or what does this whole system look like?
Well, I'd love to hear what you think. What do you think is best, and then I can answer sort of what we do. But I'm always looking for
I
feedback.
think that I've seen, use cases where, some companies like yours start out with this very robust system of controls and then end up whittling it down to like a PS5 controller or whatever it is. And then realizing that because of the general familiarity with some of these controller devices, something that's familiar, even if it's not as eloquent, is more user friendly. So if I'm picturing what I would want if I just opened up a box and got what I want, I'm not a big video gamer, but I understand how to use an Xbox controller. Like if it was something to that effect, that would
Yeah.
feel immediately recognizable and usable, right? Immediately. And then you start thinking about a dashboard or like an interface. You know, I would love to see, the screen in the middle with my pop-up alerts on one side and a selection toolbar on the other side where I can select what I want to see, kind of sitting at the helm of this whole unit. I mean, that's what I picture in my brain, whether that's real or not. That's kind of what I imagine.
Jake, you just designed it. That is exactly what we have. Like the word for word, precisely what it is. Um, yeah, we heard from users that these incredibly robust, complex, expensive controllers are hard to set up, hard to train on. We went with the most common, simple thing that people know how to use today, like Xbox controllers, PlayStation controllers, video game controllers. We have a display, incredibly bright, so that you can use it bright outside in the sunny day. We heard that from the operators. Has easy to use control scheme, average, like I mentioned, 15-second, on time. You have all your cameras in the middle, one, maybe two. We don't want to do operator fatigue. You get to choose which ones you see. Little alerts that pop up, little icons for battery life or other critical things, and you can just drive the thing, and it just sits in your hands. If you get tired, you want to sit down, great, no problem. We got outputs for HDMI, USB, USB-C, connected to a monitor, connected to an EOC, stream that data, sit down, relax. Great, no problem. But yeah, the core is exactly like you described. It's off the shelf. Firefighters use it for a dozen years. If you play video games, you're great. even if you don't play video games, even if you're a chief, even if you're someone older, maybe if you're retiring, whatever. We've tested with hundreds of people, and everyone gets up to speed really, really quickly.
Well, I think it's funny. It's like I talked on a podcast last week about using institutional knowledge and not thinking of it as a downfall, but just as being wise about how you spend your time, right? So it's like if you think about the amount of time that Sony or Microsoft has invested in making this controller as user friendly as humanly possible, like Paradigm Robotics can be the most robust company ever, but you're never going to beat Microsoft's controller budget, right? They've already done it. They solved the problem. Why do we need to re-engineer the wheel when somebody already made the perfect controller? Because if it wasn't the perfect controller, Xbox would have figured it out already, right? For real,
exactly.
Right? The problem's already solved.
Don't reinvent the wheel.
So the other thing that is a frequent problem in the fire service technology space is connectivity. Like, how do we link all the systems together? A perfect example that I'll put on blast. I don't have any affiliation with them, and I think everyone that works in the space knows. Ray Systems makes awesome monitors. I work inside the Honeywell system, but when we start thinking about the Ray Link and the Auto Ray and the Area Ray and all these Ray Systems monitors, when we put those together in the Ray Safety Suite, the connectivity frequently is a big problem. So if we could, that's my bibbity bobbity hazmat. If I could wave my hazmat wand and solve something in the hazmat space, the connectivity amongst all these technology groups is a thing that is a pain point that someone solve it and you'll make the money, right? Because these giant companies still seemingly haven't solved it. And so how do you take a system like you are pitching, or have rather, that's going to integrate all these different modular technologies that and then now put it on a UI that works and has correct connectivity that works when you need it at the time. And especially when it's not only a you problem to solve, you're also dealing with all these other technologies that you have to integrate into one place.
Yeah, absolutely. Great question. And
that was a lot of words. I'm sorry. That was a lot of questions.
No, it's good. I think you've touched on a thing that we've heard from so many emergency response or hazmat teams is connectivity is such a critical thing. Whether it's ground robots of ye old or the multi-rays, which we're all too familiar with, the area rays, sorry.
Mm-hmm.
It's a problem because we think that folks did not try to first principles it. And first principles is just an engineering philosophy to say is, let's break it down to the root cause and ask why along the way. How do we do this from the most practical possible way? And so what we started realizing as we started thinking about wireless comms with our robots is, what is the environments we're deploying into, right? So we have interior structure or no line of sight environments. We have buildings. Then we have maybe refineries or industrial facilities, also no line of sight, but sometimes outdoors. We have train derailments, large outdoor scale exercises, and many others that fit into all sorts of categories. And we started thinking and realizing that, okay, well, wireless comms is really important. These robots are going to go sometimes a close distance away, sometimes a far distance away, with obstacles, without obstacles. We need a way to be really, really reliable. And some of the challenges with the previous systems of the old did not really think about that system in a way. They kind of threw on or slapped on radios from other providers that work in some great line of sight environments, but not others. So we first made ours dual band, right? We use cellular. We have the ability for satellite as well for our large robots, but we can, go over the air through cell towers. But if we just stop there, then you might lose connectivity deep in a structure or sometimes in places where there wasn't actually connectivity from cellular. So then we have incredibly strong point-to-point radios. We integrate. We can use commonly available companies. I won't drop company names, but we can use 1 watt, 6 watt, 8 watt, 10 watt radios. And we're able to get very long range. We've done about 200 miles line of sight. And we've done 10 concrete walls, 16 inches thick with rebar and piping, no line of sight. So very, very deep structure. So whether it's sub-T, subterranean, or deep into like a large big box. And you might be asking, well, how do we do that, right? Like, we aren't reinventing the wheel. I'm not reinventing radios. But what we do is we work very heavily on antennas. There's so much research and science that goes into antennas, and we spend a lot of time in the company. We've designed our own custom antennas or in custom cables or in custom systems to help improve that. So some special technology that really makes sure we amplifies our gain. We're in the right direction. We're using the right antennas, the right polarization. Then we write software for the radios and our data to compress and encrypt and make sure it's in the right format so that we can get very reliable comms, even at very long distances or in poor denied environments. So making sure that we can retain very, very low consumption so that you can actually get those better communications. So long story short is we're not trying to reinvent radios. We integrate with whatever the department uses today. If they use Motorola, we can integrate with Motorola. If they use Persistent, we can use Persistent, Silvus, Doodle, whatever the department's using, we can integrate with so that we can mesh and bounce off of things and be a repeater for firefighters. But our core mentality has just been solve each problem, use dual band for more reliable communications, do the software work, do the antenna work. And we've ended up creating a product that um, not to toot my own horn, but it's a great wireless comm system that won't let you down when you really, really need it. And even in the worst case scenario, it'll come back home so that you don't lose it and you get all that data back. And it won't impede the way of other firefighters because it'll fail safe. So a couple things like that, and we end up making a reliable product.
So as we look to start wrapping up here, I want to take a view into the future, right? We know what you have now. What is Sidd's view of the next decade or the next 2 decades of what is potentially possible, but not necessarily attainable today?
Yeah, it's a good question. I'm really excited for the future. I think it's going to be a great future for everyone. I think I'll touch on maybe some subjects that I know about is, maybe robotics and emergency response. And I think that what you're going to see is more and more integration of technology in the fire service. But I think more than just seeing more of it, I think you're going to see more adoption, more ease of use, and more SOPs and reports and audits and all the actual legal structures that underpin a department's work working with robotics and AI and automation because it's going to make jobs easier. It's going to make jobs faster. It's going to make people spend less time doing the things they don't want to do and more time doing the best parts of the job. And I think really looking 10, 20 years in the future, I'm excited for some of those problems I talked about. EV fires, staffing issues, doing more with less funding, being supported by technology. Because I think one of the key things that technology does is not just make safer, but not just do faster, but also drive costs down, right? Are you able to save bottles, save suits, reduce incident time so you can reallocate resources to drive increased funding, to drive, more people with less, or doing more things with less people. So I think the future is going to be great. I think robots are going to get better and better. We're going to have more and more autonomous features to reduce burden from operators even more and drive further and further value for emergency response teams. And I think we'll make our robots more and more cheaper, scaling it down so that we can drive greater adoption and see them everywhere. And I think we're going to always be learning. There's going to be new threats on the horizon, from nuclear to hydrogen, and thinking about how to solve for those will be always a problem. But yeah, I think robots technology will be great, and I think we'll see more and more adoption.
Is there any chance that the singularity will happen and robots will take over the world like Terminator?
Beats me, iRobot or Terminator. Oh man.
Is it?
I think
I asked that tongue in cheek as a joke, but like as someone who actually understands that problem theoretically, if this was a real problem, is that a thing that even kind of crosses your mind in terms of any concern that there would be like some like this is the new discussion. AI is going to take over, and then eventually it's going to be kill all the humans, right? This is not a real problem, right?
Yes, not a real problem. But I have to leave you hanging for a second.
Yeah.
No, I think I think I get it. I mean, it is definitely a concern. I think one of the things we want to do is make sure that the folks building all the things, making all this technology have the right people with them who understand the problem or in the field, understand the ethical issues, understand the real world issues, make sure that we're building things that are safe. I don't think we'll have a Terminator iRobot situation. I think robots have a lot of work to do. AI has a lot of work to come. And I think that the pace and average sentiment of people building this technology is safety first and making sure that what we're doing is reliable, does no harm, and supports, the people that it's working for. And I think in terms of the singularity, I think what's really exciting is we're already seeing, new and new jobs and economies and productivity from all the things we're building. And that's opening up just wide new career paths, like the same way the horses turned into car manufacturers or typewriters turned into office work. And I think you sort of drive productivity forward while increasing human GDP and human happiness, which is so important. And so I think whether or not the singularity happens and whether or not the singularity happens, even if it happens in 10, 20, 30, 50 years, if it ever happens, I just know that this pace of change and the pace of progress and the pace of technology is only a good thing for humanity. And, we do all of our part to make sure it's safe and reliable and positive. And no, I don't think there's no cause for concern right now. I'll let you know if that changes,
If
though.
that changes, I
Um,
want a text, please. If I need
yeah, if
a
my
red
robot
alert.
wakes up at night, yeah, if my robot wakes up at night and starts
Yeah.
racing down the office, I'll call you, man. I'll let you
Okay,
know.
perfect. Thank you. Sid, man, thank you for joining me. This has been awesome. I learned so much. I'm so hopeful. I would love to get a robot up here to see at some point. I haven't seen one yet, but I would love to get one out to Minnesota to see and play with
Oh,
at
we'll
some
do it.
point. But yeah,
We'll do it.
I
I'm a
really appreciate
Wisconsin
you, man.
lad, and I want to go back to the homeland.
Perfect. Yeah. The conversation was great. The insight's amazing. It's amazing what people are doing in the space. And thank you for the work you're doing, man.
Thank you, Jake, for having me. I had a great time. This was incredible, and I'm excited to keep supporting the fire service. So thank you for your
Awesome.
time.